Hey everybody, welcome to QuickSilicon. In this video, we'll be going over the logic from waveform problem. This is one of the sample test problem which we have on our website, and it's a very easy problem to solve, but our data internally shows that a lot of people have trouble getting all the test cases to pass in the first time. Usually they get a couple of them to pass, but they fail on the third one, or sometimes they tend to get just one test case to pass. And a lot of time the error is within the HDL code where they have actually missed one small condition, or probably they are not using the correct reset. So let's look into the problem and how we can actually solve it and get all of those test cases to pass. So the problem statement specifies that we need to read this waveform and then implement the logic whether in Verilog or in VHDL. We'll be going over the Verilog implementation for this. The problem also mentions that all the flops should be positive edge triggered with asynchronous reset if we want to have any flops. So we'll see that if we need any flops for here, then we should implement them to be positive edge triggered with asynchronous resets. Okay, the problem also has the following two conditions here. It says that the counter should reset to a value of 4 whenever we get the input AI, and the counter should restart from 0 when a value of 6 is reached. Okay, so this is probably a hint that we need to implement a counter as the problem clearly specifies here, and the counter should behave in a fashion where uh, whenever the input AI is asserted, we should give a value of 4, and whenever the counter reaches a value of 6, it should then roll over to a value of 0 and start again from there. Okay, with all of this information, let's try to read the waveform and then further try to decide on how the counter behaves. So in the first few cycle, we see that the reset is asserted and the output here is 0. So I believe this Q underscore O output is nothing but our counter output. So as we see that once the A underscore I input is asserted, we move on to the value of 0x4, which is as per the given specifications. And if the input AI is not asserted, the counter continues to increment by 1. So that is why we see that it was 4 here, and then on the next cycle it moved to 5, and on the next cycle it moved to 6. Also, we do see a case where the current count value is 6 and even the input AI is asserted. As per the waveform, what we see is that the input AI has more precedence. That is why the counter becomes 4 instead of becoming 0, which means that if AI was not asserted here, we would have gone to 0, but since AI was asserted, we went to a value of 4. And then similarly, on the next cycle, we incremented the counter by 1. So basically what we understand here is that we need to implement a counter. Counter will continue to increment by 1 until it reaches a value of 6. And if it reaches a value of 6, then we should reset it to 0. And at any time, if we get the input AI on the next clock cycle, we should reset the counter to a value of 4. So that is what the problem statement specifies. Let's try to implement the RTL for it. Basically what we need to do is we need to first declare signals for implementing a counter. So let's have them as reg 2 down to 0 count underscore q, which will be the current counter value, and similarly let's have reg 2 down to 0 count let's call it next underscore count, which is the next counter value. For implementing the counter, we'll need some set of flops. So first implement those flops. So for those flops, we'll have always @posH clock or posH reset. If we are in reset, then the count value, the current count value should reset to 0. We'll have 3 tick be 0 0 0. Otherwise, we should assign the current count value to the next count value. So this completes the set of flops which we needed for the counter. Now we just need to implement the logic for the next count signal. What we need to do is basically we need to honor these two conditions, which can be easily done using a ternary operator. So as a result, I don't think so we need a reg here. So instead we'll just need a wire, and then we'll just have a assign statement for the next count signal. So we'll have assign next count equal to whenever we got our input AI, it should reset to the value of 4. Otherwise, we should check if our counter has reached the value of 6. So we should have count underscore q equal to 3 tick h 6. If this is true, then we should reset it to 0. Otherwise, it should be the current count value plus 1, 3 tick h 1. So this is how our next count signal should be driven, and this basically completes the entire implementation of the counter as per the given conditions and the waveform. Now we just need to assign our output. So our output would basically be q underscore o equal to the current count value, which is count underscore q. So this completes the entire RTL implementation for the logic from waveform problem. Let's quickly run it and see whether we get all the test cases to pass. So as you see that the compilation was successful, the lint was also successful, and all the test cases also passed. So if you enjoyed watching this video, please hit that like button and do subscribe for more such videos.